Yesterday, in continuation with our project management, yesterday we were talking about the network technique. I continue with the same topic, network techniques. In network technique, we were talking about the part and the CPM. What is part? This is program evaluation review technique. What is there in the CPM? This is called critical path method. Now we will deliberate, or rather we will distinguish what is the basic difference between the PERT and CPM. We'll take the two distinguished points. On the basis we will decide what is the difference between the PERT and CPM. Let me have in PERT, as the word indicates, is the program evaluation. This is the first point of difference. On the basis of this is applicable for the non-repetitive jobs, non-repetitive projects or jobs. This is for repetitive. I will discuss the difference between the repetitive and the non-repetitive projects and the jobs. And if you look at here, we going for any space mission, going with any space mission. Only few has taken place in last few years. But if you talk about the repetitive, there are repetitive jobs which are there. Building, construction of a road, construction of a road, construction of a house, or any other items. This is repetitive in nature. This is non-repetitive in nature. Another thing is, it is based on the probabilistic theory. It is based on as the word indicates, or when we are talking about the space mission, we don't know what is going to be happen there. This is probabilistic in nature. And this is another point of difference. For the CPM, this is deterministic in nature. This is deterministic in nature. Another point of difference when we are there are three time associated. There are three. Once it is a non-repetitive as well as the probabilistic in nature, means we don't know the exact time. There are three time estimates. And what are that one? I'm going to discuss in detail. The first point is this is the optimistic time. Optimistic time. I will deliberate on this one also. Optimistic time. Another one is the most likely time. Most likely time. And the third one is the probability that is the pessimistic time. Clear? What is the optimistic? Optimistic means, let us assume if I say 3, 4, 5 hours are being taken in a PERT model. 3 hours, 4 hours and 5 hours. In that case, this three is the optimistic. This is the optimistic. 3 is the optimistic. Means the minimum time out of put it in a chronological order with in the ascending order. The left side is the optimistic. 4 is the most likely time, and 5 is the pessimistic. Means the person who is thinking little bit negative, even he is taking 5 hours. So this is 3, 4, 5. And here it is, there is a single time associated, because this is the deterministic in nature, there is a single time associated. Single time estimate. What is single time means there is only one unique value. Either it will be only this, maybe I say only the 4 hours being taken to complete this project. So this is and moreover, this is the event-based model. This is event-based model, and this is activity-based model. Number point of this is activity-based model. We'll deliberate on this one also, activity-based model. Now, this is little bit the common point of difference between the PERT and CPM. Now, when we are talking about this one, I am talking about the network logic also. Continue with this one also. I will talk about the network logic. What is there in a network logic? There are few terms which are related. One is called activity, another is called event. Let me have one event, one activity which is taking place. Means pattern or making a pattern of the impeller. I'm saying making the pattern of an impeller. This is the one activity making the pattern of impeller. So this is the activity which is taking place. So I am just putting it here. If I put a one circle on a at the tail end, this is the tail end, this is the head end, this is the head end. On the arrowhead side, this is the direction, this is the head end. These two circles are known as event. Event or other name is node. Other name is node. So this in network logic, there are two terms which are related to this part and CPM. I'm deliberate on this one. This activity is making the pattern of the, if I say the start of making of the pattern of the impeller, this will be placed here, and the end or finish of making a pattern of impeller. This is called events, start and end. It represents the event, and this represents your activity. Another thing, this is called the path. This is called the path. The movement from one place to another one is called the path. Another one, network. In network, what happens? Here there is only one activity which is taking place. If there are more than one activities which are taking place is called the network. Another one, how to construct the network models. That we will take separately in the next class. We'll deliberate on this thing on the next class also. And another thing, there is another concept, dummy. Dummy means, what is the dummy activity? Dummy activity, it is just to, it does not consume any resources, but it assists in the completion of the network. So this is called the dummy. So another thing is called the looping. Sometimes what happens, dummy means I take this one, maybe here, this is another activity, this is another activity, and from next activity means this dotted line, this shows the dummy and it does not consume, but it is representing the another activity, means this is the start of another activity. This is activity A, this is activity B, and C activity, which is dependent on both B and C, B and A. For that, we have to introduce the dummy activity. Clear? So it does not consume any resources, but it helps in the completion of the network. Is the role of the dummy activity. Another is called the looping. I can say another concept. This is the one. This is another one. This is another one. This is another one. If you look at here, there is a closed loop which is going on. You can start it from anywhere. You can start it from either 1, 2, 3, or 2, 3, 1, or 3, 1, 2. You can start it from anywhere, but these types of activities are not going to take place in the network model. If these types of activities are being taking place, means we are not able to finish our end point. So this is a little bit about this network logic, where we have discussed the activity event, then we talk about a dummy, then we talk about the path also, then we talk about the looping also. So we'll take one more concept that is called the Fulkerson rule. I take one concept, this is the last concept which we are going to talk about in this, that is the Fulkerson rule. Fulkerson has scientists who have given the rule for this, how to, when you are able to make a network model, how to number it. So let us assume this is the model which is given to you. This is a model which is given to you. I take one example related to that one. This is the last example which we are, how to number it. We'll discuss that. I have put a arrowheads here. Number, how to number it, we'll discuss in detail. Clear? So we will discuss these things here. Now let us how to make the numbering system of this one. And similarly, maybe from here to here also, both the processes which both the routes are being followed here. Now this is activity A, this is B, let us assume this is C, this is D, this is E, this is F, this is G, this is H, this is I, this is J. Now here, if you look at here, if you put a arrow, consider the first one. Two arrows are being taking place. The initial one, according to the Fulkerson rule, will number it. Even if we number it in a staggered manner, it is not going to affect. But the Fulkerson has given the best way how to this. The name of the scientist is the D.R. Fulkerson. According to the Fulkerson, or according to the D.R. Fulkerson, we are going to number it. This will be the number one. These are called, these circular parts are known as the activities or node. These are called, event or nodes. Whereas this A, B, C, D, E, F, G, H, I, these are called activities. A, B, C, so on, up to the point J, these are called activities which are taking place. So how to number it? I have number it 1. Now accordingly, here two arrows have been taking place. So you will number it 2 and 3. Once you have reached at 2, again two directions are taking place. So again two directions are taking place. Do the numbering. We have reached up to point 3. This was the number 3. Now number 2, this is the 4. Similarly, you can number it 5. Two events are taking place. This is called 4, this is called 5. Clear? This is the arrowhead. From here 3. Again, two events are taking place. This is the 1. Already number 5. This is the number. You can number it this as a 6. This is the 6. And once you have reached it here, from here, there are 3 which are merging at a common point like this one. So this is, once we are reached at 6, this is the number 7. So this is the way you can numbering according to the Fulkerson rule. You can start with the 1, 2, 3, 4, 5, 6, 7, or you can take a multiple of 10. So similarly you can 10, 20, 30, 40, 50, 60, 70. Even you can take the multiple of 5 also. This is 5, this is 10, this is 15, so on. You can do the same pattern also. Even you can take a multiple of 3 also. Even you can take the multiple of 2 also. So this is the way you can do the numbering system also. What we discussed today in a class, we have discussed with the network model. In network model, we talk about the difference between the part and sequence. Then we go to the network logic. In network logic, we discuss the term activity, event, path, then network and the construction of network. And then we talk about the dummy and the role of the this looping system. Then in the last video, we have made one network which is already available to us. What we have done, we have make use of the Fulkerson rule to do the numbering in a systematic manner. That's it from my side. If you have any question, that's it. Thank you very much.